All right, hi again, everybody. I'm gonna begin an overview of single subject research designs, also called single case designs. Single case research is probably the term that you're going to see. It's a little bit more of an updated term, but you're also going to see single subject. That's the term that I was raised on, so that's the term that I use. I've given you this PowerPoint slide deck here that I'm using. We're going to talk about functional assessment, which is at the end of the slide deck in more detail when we meet on Monday. And it's that reading and these slides just as a supplement that I'd like you to base your reading response on, and I'm going to post that. Now, I'm going to make that because, again, this is Thursday, and I understand this is you have not had, and it's my fault yet again. You haven't had enough time to do this. So I'm going to make that reading response very minimal. Instead of, for example, 3 questions, I'm just going to have one important question. Just ask you to respond to that, and that'll be up here in just a minute. But I'm going to lead you through a discussion of single subject research design, talk to you about why we use this particular research methodology. It is the approach to research that you're going to see most often used in special education. There's a really specific reason why. Why do you need to understand this? What does it have to do with you working in classrooms? A lot. A lot of what we know to be the best practices, the practices that help kids improve their academic performance and improve their lives, have come from research that was conducted with this logic and the inferences that we make from that research. So let's talk about the very, very general types of research designs that are out there. Now, first let's talk about group experimental designs. In medicine, for example, medical research is nearly always conducted on what we call double-blind group experimental designs. You've got a group over here, group A, and then you've got group B over here. Group A is given a particular drug, and group B is not given that particular drug. And then you make a comparison between group A and group B, and if you see differences, then the difference is attributed to the variable that you have imposed, the independent variable. And in medical research, in those cases, it's a drug or a treatment or something like that. So what we would infer from that is that the drug has an effect. Hopefully it's a positive effect, and there are no side effects. But the way we do that is by comparing groups of people. One group gets something and another group doesn't get something. One group is the intervention group and one group is the control group. So with these group experimental designs, the inferences that we can make between a variable and the outcome, between doing something and whether it has an effect, is very, very strong if the research is done well. It's good stuff. Usually group experimental designs are kind of the gold standard for research. I mean, that's that's why it's used most often in medicine, because the stakes are really high. The problem in special education is that we really don't have groups of kids together so that we can conduct research. Usually with group experimental designs, you need a minimum of 30 to constitute a group, and that has to do with statistical reasoning. But it's just true. Sometimes we only have 1 or 2 kids. So single subject or single case research allows us to make inferences regarding the effects of an intervention or the effects of an academic intervention, a behavioral intervention. With collecting data on even a single individual or a small group of kids. And there are different ways to do it, and there are different reasons that we do it, and therefore designs for setting up the research. One thing that you want to be able to understand is the difference between a dependent and an independent variable. This can be a little tricky. to boil it down though, the dependent variable is always the behavior that's targeted for change. The independent variable is the intervention that's being used to change the behavior. The independent variable doesn't ever change. That's why it's independent. The dependent variable, it is dependent on something else. It is subject to change. And if you want a little mnemonic, the independent variable is the intervention. Okay. I gave you a little worksheet on that, and that's here. Independent and dependent variables. That's on your Moodle website. Here you have the I made an answer key for that. So the independent variables are coded in yellow, and the dependent variables are coded in green. What I would suggest is that you go ahead and try to do this. Don't use the answer key first. Take your best stab at it. Compare your answers to the answer key. If you're wrong about something and you can't figure it out, circle it, note it, bring it back to class, and ask a question. This is, again, it's tricky, but it's not that tricky. So this is one of the fundamentals about understanding research. You've got to understand the difference between a dependent and independent variable before you can really understand and interpret research. And that's really the object of for you all at your level of study. I'm not looking for you to be producers of research. I'm looking for you to be consumers of research. Research-driven teachers. There's a lot of stuff out there that when you have questions and you understand how to find good research and you understand how to read and interpret it, you can really identify very efficiently solutions to problems. You can adjust your teaching in really productive ways. I've selected some articles for you to read a little later on, gradually, and that's why you're doing the article review, is to kind of ease you in to exploring this this body of knowledge that we have out there that is beyond the classroom. It's beyond a textbook. And to show you what an important resource it can be as you move forward in your teaching career. Sorry, I was reading something. So often what we are attempting to demonstrate is whether there is a functional relationship. You can also think of it as a meaningful relationship, a cause and effect relationship between the independent, the intervention, and the behavior that we sought to change. Does my intervention, my action as a teacher, result in a change in the behavior that I sought out to change? If it does, hey, keep doing it. If it doesn't, don't do it anymore. Don't waste your time. Don't waste the kids' time. And let's do something else. The only way that we can ask those questions and answer them validly is to have some kind of data collected in a systematic and intentional way, and we interpret it with some kind of accuracy and objectivity. All right, so we're going to talk about these very basic research designs: the A/B design, reversal, changing criterion, multiple baseline design, and then these other two. The most fundamental we call the A/B design. You can think of this as a pre-post or a before and after design, a baseline intervention design. The A/B design is what it's called in sort of the world of single case methodology. What we have represented here is behavior before we do anything. The dotted line, as we talked about before on the graphing instructions, represents when we did something. We imposed an independent variable, an intervention. So we have low levels of behavior here. Let's say this is on-task behavior here. It's not labeled. But right now this is low levels of on-task behavior. We introduce some kind of intervention. Let's say a token economy. If you're on task, you get a certain amount of the reward. And afterwards we see that the behavior has changed in the level, and the behavior is also trending upward. It would make sense that if this is going from here up, up, that tomorrow it's going to go up, up, up. That's good. The inference that we could make would be that whatever we did here probably caused the change in this low level data to this higher and trending higher data. Whatever you did here, likely you should probably keep doing it. But can we say scientifically that there is a functional relationship, there is a cause and effect relationship between this intervention and this change? No, we can't. Because, and why not? You need to know why not, and this is very clearly explained in your reading. The reason we can't is that we only have one demonstration of this change, meaning that even though we do see a change, a very clear and rather dramatic change between low levels of behavior not happening much and then behaviors happening more often, and it seems to coincide with this intervention that I did in my classroom, it's possible that this kid and something happened at home, like dad got out of jail or something like that. And I don't say that, I mean, it's not meant to be a joke. It happens. Or some other factor by chance happened simultaneously. Maybe the kid who has always pestered and oppressed this kid moved away, and the kid was no longer in the classroom. And it happened to coincide with you're using a token economy to help get this kid on task. Well, really, the change might be due to some family factor changing or some school environmental factor changing, and it just by chance coincides with your intervention. Your intervention may be really ineffective, but if it coincides with something else by chance, you could make a faulty inference. You could infer that your intervention is effective when really something else is going on. So the A-B design does not demonstrate a functional relationship. It can suggest one. That's all it can do. Now, sometimes for the sake of teaching, if the stakes are not particularly high, no big deal. We can use this and we can kind of move forward. But let's say that we want to demonstrate a functional relationship and make a higher stakes decision, like make a really fundamental change to a kid's program, or the intervention is really expensive. We want to know for sure if this works. So despite the fact that an A-B design is simple, it can't be used to make a functional relationship. It doesn't provide for replication. We're not saying, yes, we saw it happen once. We don't only see it happen once, we saw it happen several times. So instead, if what we want to do is prove with scientific certainty that there is a functional relationship between independent and dependent variables, we need to do the ABAB or reversal design. Sometimes it's called a withdrawal design. You can think of it as an ABAB or a reversal design. For us, for our purposes, those are interchangeable terms. So here we would see baseline, we do something, and then the behavior starts to decrease. Let's say this is aggressive behavior. It's real high and it's steady. We do something, and aggressive behavior decreases. If that's all we do, we have an A-B, a before and after. Now, it seems like whatever we did had an effect. But again, there's this chance factor. You know what? Let me back up. Let me say this is not aggressive behavior. This is disrespectful behavior. And I'll tell you why I'm having to back up in just a second. Disrespectful behavior. We do something and all of a sudden disrespectful behavior, disrespectful verbalizations decreases. Well, let's say I instituted token economy. I'm reinforcing absence of disrespect. That if you reduce your number of disrespectful interactions with me, I will give you some kind of reinforcement, and so it decreases. If what I want to do is verify, then what I have to do is I have to take the intervention away. So that's what this second intervention line represents. Here I impose the intervention. I start doing something, but here I take it away. And look what happens. The disrespectful language starts to increase. The kid's no longer getting reinforcement for decreasing disrespectful language, and the behavior starts to increase. What do I do here? I reimpose the intervention, and the behavior starts going down again. This before, after. Go back to the before and then after. Baseline, intervention. Back to baseline, back to intervention. I saw this have an effect. I saw this intervention have an effect once. I saw it have an effect here because when I took it away, it started going back to where it was. And then I saw it have the same effect here. 1, 2, 3 times. Now, in an A-B design, it's possible that some chance factor, dad gets out of jail and all of a sudden the kid's in a better mood and he's not feeling too disrespectful. Yes, that could account for some change like that. But what's the likelihood that a chance factor would coincide with 1, 2, 3 times my manipulating this kid's environment, not his behavior, his environment. Very, very low. This does pass muster. All right, this is valid to infer a functional relationship. If I saw data like this, I could, with a fair degree of scientific certainty, say this intervention caused the change. With the A-B design, I can't say that. It suggests it, and I could probably, just move forward and teach based on that, keep my eye on it. But with this is verification. All right. So the advantages are it does demonstrate a functional relationship. We can say with certainty that the intervention causes the behavior. If an intervention, let's say, is really expensive, we darn well want to know, does it cause the behavior or does it not? Because if it doesn't, we don't want to spend the money. We don't want to spend the manpower. Here are the drawbacks. It doesn't work if we're teaching new behaviors. And why is that true? Well, if, for example, this is, let's say this represents a high level of some kind of like disrespectful interactions with peers. And my intervention is I teach the kid a specific set of social skills. I teach the kid a sequential social skill of how to deal with conflict. And then what we see is that the behavior starts to go down. Well, I can't take away the fact that I taught that kid something. Okay, I don't have the opportunity. So if I'm teaching a behavior, I can't take it away. Can't use this design. Now, a token economy is something that I do all by myself. I can either do it or I can take it away. So with behaviors that are taught, behaviors that change the kid, withdrawal designs don't work. And we also don't want to do it with behaviors that somehow compromises ethics, specifically aggressive behaviors. If I see that, let's say, a kid is hurting himself or hurting other kids, and I intervene, and all of a sudden I see that that behavior decreasing, well, that's a good thing. It wouldn't be ethical, for the sake of scientific verification, to take that intervention away and risk the kid hurting another kid or hurting himself. In those scenarios, what we do is we call it good and we just move forward. It is unethical to take the intervention away if there's the risk that the kid is going to hurt himself or others. Changing criterion design. This is another design where it's really good for academic behaviors. So with a changing criterion just means goal. We set a goal. So for this, this is a very low index, 1, 2, 3. So let's say this is a behavior that we want to increase. So let's say this is a kid who's doing 2.5 math problems on average when most typical kids are doing 10. Okay, right now this kid's doing about 2.5. I say, you know what? I'm going to intervene. This line should be dotted right here. And if you do 3, okay, I will provide some reinforcement. And we see that on average, this has increased. And then what we do is we change that criterion. So we gradually say, now I want you to do 3 to get reinforcement. Once we get 3 consistently, I want you to do 4. Once we see 4, I want you to do 5. And you can use this gradually to increase expectations. It's great for academic behaviors, shaping behaviors gradually. Because remember, we want to use our professional judgment to see, to decide how much progress a kid can feasibly make. Yes, you can show a functional relationship with this design, and you don't have to take anything away. Very unlikely that chance factors would result in the change from here to here to here to here. That chance would coincide with these 5 changes. Bring questions about that. Now, multiple baseline, this looks more complex than it is. What this allows us to do is, and how I explained before with the AB design, the withdrawal design, you really can't do anything that you can't test. You can't withdraw anything that involves teaching. The multiple baseline, it can be across students, across settings, across academic subject areas, even across different behaviors. This is the solution to verifying whether there's a functional relationship between interventions that involve teaching. So if you look at this, percent of steps correct, steps of what, I don't know, and this is Tawana, okay? So we have Tawana, Richard, and Juan. So this is multiple baseline across students at the beginning during the A, B, okay? This is before, after. Just take a look at that for now. Tawana has percent of steps correct, not even half, 40, 30, 40, okay? I intervene, and all of a sudden she's doing 90 to 100% of the steps correct. Well, that's good. Does this show a functional relationship? No, because this could be coinciding with something else. So what I'm going to do is I'm going to find another kid like Tawana who is in need of an intervention. Percentage of steps correct on the same task, whether it's math or reading or some kind of procedure. So I collect baseline data, but while she is in intervention, okay, you would see this would coincide here right on day 3. So if there's like some school change going on, well, it's not affecting Richard. Richard's percent of steps correct remains low, even though hers changed. Okay, so what I do is I impose the intervention where I impose the intervention on day 4 for Tawana. I give Richard the intervention on day 8, and I see the same change. So I see a change for here, before, after, for Tawana on day 4, before, after for Richard on day 8. Do the same thing for Juan. See, Juan's still really low, but I only intervene with him on day 11. Now, all these kids go to the same school, so this accounts. I see before, after, before, after, before, after, on 3 different days across 3 different kids. This allows me, even though this is really just an A, B, A, B, A, go back, A, B, I've done it 3 different times on 3 different days with 3 different kids. This does show a functional relationship between the intervention, the same intervention here, same intervention here, same intervention here, and the behavior. Okay, the percent of steps correct. Now, it has to be the same behavior for all 3 of these different kids. And it has to be very similar conditions, but we're doing it on different days. This does work for behaviors that change the kid. It works for behaviors where we teach the kids something new because we don't take it away. It involves no withdrawal. So that's a very that's one of the more sophisticated designs. It's not as complicated as it looks. It is labor intensive, and you can talk to me about that. The changing conditions design, you can think of this as an A, B, C. If I've got intervention number 1 and intervention number 2, let's say I want to try a token economy for a percent correct, and even percent correct, let's say some kind of an intervention that I don't have to take away, even a teaching intervention. And I do that here, and we see a little bit of a behavioral change. Then I do intervention number 2, something different, and I see this big jump here. Well, the difference between A and B and A and C is much bigger. Okay, here's the difference here, but then here is the difference here, bigger. So what I would then be able to infer is that intervention number 2 works better. Don't do this, do this. How many times, yeah, it took 16 observations. It would take a couple of days, but it's worth it because I know, don't waste my time with this approach to change. Do this. My phone is ringing here. Got to pause, be right back. Yeah, wrong number. All right. Now, the thing here is that we can't verify a functional relationship. Why not? Well, really, because this is really just an A, B, A, C design. I can tell which one of these seems to work better, but I still can't verify whether intervention number 1 or intervention number 2 caused the change. I just get kind of a light suggestion that this one works better than this one. For my money, do this one, don't do this one. Okay. Now, you could, if it's possible, you could withdraw this, probably see a change that would head back to baseline, and then reimpose it. So essentially, you would do an A, B, C, A, C, and I can show you all this too if it's confusing. But you could withdraw it and then have some verification. But that just makes a comparison. The alternating treatments design, there are a couple of examples in the book, and there are times when you might be able to do this. You can do this with approaches to teaching. So we've got, again, I always use number correct or being on task, these silly concocted examples just because they're easier. But you got numbers correct. Now, with this, each one of these coded shapes, the diamond and the larger square, represent a different intervention. When I use intervention number 1, let's say I use a token economy. The more you get correct, I will give you points towards your token economy system. Or number correct, or on instead of that, that is represented. That intervention is represented here. Just reinforcement. Do more, get more correct, and I'll give you some tokens for our system, and you can trade it in for the treasure box later. Or what I do here is I offer direct academic support here. I work with the kid directly here. Here, I'm just saying, if you get more right, I'll give you some reinforcement. Here, I'm saying I will work with you directly, and I'll give you reinforcement. All right. So on day 1, I do this. On day 1, token economy. Day 2, work directly with the kid. Day 3, day 4, token economy. Day 5, work directly with the kid. Token economy, work directly, token economy. So you can see how really these are sequentially in a line. But if what I do is then separate out the days that I worked with the kid directly and gave direct academic support, or just gave reinforcement and no academic support, I can see that academic support results in an increase in the dependent variable, the number correct, the behavior of interest. So what do I do? What is the inference? This kid needs academic support, not just a carrot stuck in front of him dangling, saying if you do more, you'll get a reward. This kid needs academic support also. Some kids just need an incentive. Some kids don't. And this is one way that you can actually make that distinction. This, sort of like the ABC design, is a way to compare. Now, what's the advantage here? I don't have to collect baseline data. I can just jump in. Sometimes you need to do that. Alternating treatments can be great for teaching because you don't need to collect baseline. And yes, you can make a functional relationship. All right. From there, now I know that was quick, but that's kind of the name of the game with this. I want you all to bring questions regarding graphing, selection of data collection systems, anything related to your first applied activity, and single case research. Remember also to bring your article that is due for me to approve. I'm pretty sure that's you all. And if that's inconsistent, I don't have the syllabus in front of me, but I do want to see the article that you are going to use for your critical analysis. I would like it to be an experimental article. Single case research design would be great. It doesn't have to be, but ideally that would help you become familiar with that. You've got these slides on functional assessment. They don't take the place of your reading. They augment your reading. These slides and the notes herein don't come from your book. They're an extension of your text. So make sure to read that section pretty carefully. Chapter 5, as long as you get the kind of the basics that I've touched on, that's fine. This chapter is really the linchpin of applied behavior analysis. You want to read this one word for word and understand it. And if you don't understand it, make notes, bring questions, and we'll figure it out when we meet in class. All right, I will check email between now and the weekend, and I'll make sure to respond to any questions you have. If not, I will see you on Monday. Oh, and I've also uploaded 2 links to YouTube videos that's a nice overview of classical and operant conditioning, and you can watch both of those. It's only about 25 minutes total between both videos, so it's worth watching, especially if you're confused about the principles of operant conditioning, positive negative reinforcement, extinction, punishment, or any of the principles that are associated with respondent conditioning. That's Pavlov. Conditioned and unconditioned stimuli. They give some nice examples in there, and it's presented in some nice plain language. So I think that's worth a watch too. If you have any trouble with these links, let me know, and I will do my best to fix them. Take care.